and good morning. It is Wednesday, I believe. It's day 3,562 of the pandemic, and we're going to get going. All right. So the task for today is going to be looking up a little bit more of the, poking and prodding Dynamodb a bit. We had been looking at, let's see, some of the other documentation on it, getting a little bit more of an understanding of how to model tables in AWS, in DynamoDB. Hey GT, good morning. How are ya? I wonder, can I... Lambda and DynamoDB? Yes. I really want to get that working. One thing that I miss when I have the browser on the screen is the console bits, the chat. So I'm going to try to get the chat on that screen for a moment. All right, got that there. Got read chat running. I'm going to see now if I can get that over here. This window. All right, so I need to do a window capture. Okay, now we've got this. I need to trim that. Do an edit transform on this. I can crop the top here. All right, so let's go, I don't know, like 800 first. 850. Okay, now we'll dial this in. We can crop the bottom too. Take off that little bit there. There we go. Let's see, how's that work? I think I'm going to put that at the bottom. Move that down below. Oops. Too far. There we go. Now we can still see the tabs at the top. We got a little chat at the bottom. Looks like I can trim a little bit more off of that. We'll do that real quick. Okay. Morning, Cat Peasant. You know, we had started this a couple days ago looking through example of modeling relational data in DynamoDB. We also have this other large example here, which I'll toss in chat so people know what we're doing. And let's check. What is today set to? Yeah, that works. Okay. Dynamo. Did I misspell it? Daimana. That's not a bad name for it. Oh, okay. I'm just checking. Sometimes I do that sort of thing. All right. Coming back to the browser. All right. So we've got our little test table set up where we've poked and prodded at it. We've got some indexes. Well, we've got one index set up. I want to create another index. So we can have that and that. Now, I didn't really understand what these were applying to. Now, I understand here that says the primary key. Now here they say primary key, which makes me think database, relational database, which these are usually unique, but I don't think it is here. I think in this case, it's a combination of the partition key and the sort key that needs to be unique. The primary key is made up of a partition key and an optional sort key. The partition key is used to partition data across hosts for scalability and usability. But this is for the index. How does this actually work? Choose an attribute which has a wide range of values and is likely to have evenly distributed across patterns. What? Okay. For example, customer ID is good, while game ID is bad. This is the same as the other one, and I think it's actually. Is this actually wrong for that? And cancel. Okay. Because that's the same one. Wow, this little constrained view is a little tight. I'm gonna make that a little smaller. Okay, now we can see a little bit more. Because these were the same hints as the when you create a table. I think that it might actually be different for the indexes. So this is, I think, a global key, sort key, which I don't think this has to be across hosts. Now the partition key and sort key are supposed to be referring to columns here, the properties of elements. So if it doesn't have it, it's not actually in the index. So if we try to query using our index, we don't get anything because there is nothing that matches the global PK. We don't have that column. So if we start a search, okay, that's not there. This is a product ID. This won't match because we're looking for, this is a product ID inside of global PK, and global PK doesn't exist anywhere. I see. Okay, that's interesting. So if we go back to scan, table, start search, it'll just show us everything. Right. It's starting to sink in. So we went through the relational modeling and the adjacency list design pattern, which did confuse me a bit because it wasn't clear. I think this is the page. Yeah, here's the materialized graph pattern and the adjacency list design pattern. We'll toss that in chat. So the adjacency list design pattern. Oh, is that far behind? Because when we were in here, it showed that, well, here, let's go through the example one more time. A real-world example where this pattern has been useful is an invoicing system where invoices can contain multiple bills. One bill can belong in multiple invoices. The partition key in this example is either invoice ID or a bill ID. Oh, thank you for that, Cat Peasant. Here, I'm going to toss that in a new window. So using the preceding schema, you can see that the bill or an invoice can be queried using the primary key on the table. All bills for an invoice can be queried using the primary key on the table. To look up all invoices that contain part of a bill, create a global secondary index on the table's sort key. On the table's sort key. Okay, what does it mean by on the table's sort key? I mean, moose, I think, is our sort key, if I remember. Let's go back over here on the left side. Oh yeah, sort key is moose. How do I get rid of the right panel? Oh, I just unchecked that. Okay. Auto scaling, blah, blah, blah. Read and write capacity indexes. It has one. We have partition key and a sort key. I see. I didn't catch that before. Where they're creating a global secondary index on the table's sort key. Which in this case, okay, I think I see it now. So in the top row, we have invoice 92551, and its sort key is the first element in the next section, which is in inv_id with the value of invoice-92551, which seems really silly to me. Then it has a bill ID. And is that another column? The projections for the global secondary index look like the following. Now, what do they mean by projection? So for the global secondary index, GSI, we've got a primary key, which is the partition key. But this was set up to be the in our example, it would have been moose, our sort key. All right, what I'm looking through in here again, just to see the terminology they're using. Primary key, partition key. Projected attributes. Keys only or include everything else. I want to read more about that. Projected attributes are attributes stored in the index. They're actually stored in the index. Oh, interesting. Oh. And can be returned by queries and scans performed on the index. I wonder what the lag time is between mutating something and the index being updated. Because this feels less like an index and just another table. Local secondary index queries can also return attributes that are not projected by fetching them from the table. Oh, and they have a link to this. Global secondary index queries can only return projected attributes. Note, the projected attributes incur write and storage costs. Yes, okay. All right, after this page, I want to go look at the link that you sent, Cat Peasant. Oh, forgot to set up my phone. Let me get that real quick. Make sure that's set up. Because every now and then I dump my chat on accident. So sometimes I power cycle the Raspberry Pi. Okay. Represents attributes that are copied. Oh, I see. Projected from the table into an index. Well, they should have just said that. These are in addition to the primary key attributes and index key attributes, which are automatically projected. I see. So if you have a large amount of data, then you're basically doubling your cost. All right. For local secondary indexes, the total count of non-key attributes summed across all of the local secondary indexes must not exceed 20. You project the same attributes into two different indexes. This counts as two distinct attributes when determining the total. All right. The Dynamo paper. Yes. It started in 2004. Amazon.com was growing rapidly and was starting to hit the upper scaling limits of its Oracle database. I was actually at a different company that was having the same issues. They were trying to replace. They were actually trying to replace an in-house solution with Oracle and couldn't do it. It started to consider building its own database in-house. Out of this experiment, the engineers created the Amazon Dynamo database, which backed major internal infrastructure, including the shopping cart, on the Amazon.com website. They published the Dynamo paper, highly available key value store. The paper was highly influential and inspired a number of NoSQL databases, including Apache Cassandra, originally developed at Facebook, and AWS offering SimpleDB and DynamoDB. I don't know of SimpleDB. All right. So how long was this in incubation? So in 2012, it became a service, and in 2004, they started to experiment with it. 8 years? Wow. Key aspects of Dynamo. So what's the temperature in here? 54 almost. The relational data model is a useful way to model many types of data. Often, relational data is normalized to improve the integrity of the data. Okay. One of the most interesting findings of the Amazon.com engineers while gathering their database requirements was how their engineers were using their relational databases. About 70% of operations were of the key value kind, where the primary key was used and a single row would be returned. About 20% would return a set of rows, but still operate only on a single table. That's interesting. The join operation is expensive, yes. Okay. This decreases in response times comes with a trade-off of increased application complexity. Can you manage your data integrity issues in your code rather than your database? Which makes sense. Right, you're basically moving this sort of logic into your code, so its complexity increases. Here we get into the cap theorem stuff. Consistency versus availability. And then you have what's the P? Partition tolerance. So C, A, and then P for partition tolerance. All right, yep. And this is consistency versus availability. Infinite scalability. Right, horizontal scaling works better at larger scale. Seen that before. Just kind of scanning, because this kind of mirrors a lot of the cap theorem stuff. Right, which is this? Where you basically get to choose 3 and sacrifice the other one. So if you choose availability and partition tolerance, then you're sacrificing consistency. And so, which is also a good read. And you'll see that like standard databases, they value these two over partition tolerance. So if your partition goes down, they tend to take the whole thing down. And what they mean here is like I think this is really between data centers, because you could have like a MySQL cluster where they're all in like a local area, or like a master-slave solution where you can tolerate like the network going down between those two. You just basically go over to the other one. Where do they link the actual paper? Is that down in the references? Yeah. Then there's critiques, of course. Anyhow, let's go back. So in this case, what are they? Well, I did have one other question in here. So here they have projected attributes. So if you say it's keys only, what does that mean? So you could choose any random column to search on. I think that's what you're saying here. Hey, morning, Miguel America. So if you had a column that you wanted this table to be indexed by, you could also do that. Let's see. Ooh, guess who's been put on a project that involves DynamoDB? Watching the stream is almost working. Oh no. Oh wow. Well, if you want to take over and just teach us about this, I wouldn't mind. All right. I know I'm bouncing around a little bit in here. I just wanted to kind of refresh my memory on this portion here and what they meant by projected. So here, projections are the copied values that are in this secondary index, global GSI. So if that's the GSI, here's the actual table, which means that, let's see, create a global okay, I'm trying to read through this again to see where they created their global secondary index. To look up all the invoices that contain a part of a bill, create a global secondary index on the table sort key. I see. So that means that you can search through this by the partition key or the sort key. But when you do the search based on the sort key, scan, I'm going to use this. Whoa, come back. No, we want a query based on this. Okay. Yeah, it's still, you have to look up by the key ID. I see. I mean, that makes sense. So basically, you have a table, right, and you can look up things based on the product ID. Yeah, well, excuse me, the partition key. I keep thinking about this in terms of primary key, and that's holding me back. So we have a partition key, and then we have a sort key. So given the partition key, you can then find things that match. So if you have, going back to a form, does somebody have a form that we can link to? Just some nondescript, is there like a Rust-based forum out there? Or let's just find something in the community that we could kind of model. Internals forum. Hey, look at that. Users forum. Look. We'll come in here. All right. So in this case, we've got a forum. And if we were to try to model this, here we have a topic. At least that's what I tend to call these. Are these tags that they have on the topic? That's interesting. Like help, tutorials, announcements. All right. So we have a site. The site has a forum. The forum has topics. Now, this doesn't seem to have, oh, it does have categories. Oh, I see. But that's kind of the tags I was looking at. Interesting way. They kind of flipped this. Because sometimes you would have these divvied up where you might go into like the OSX portion or the Windows portion. Let's say it was like some divvied up that way for whatever reason. I don't know, I'm making stuff up. But instead, they just have one big listing, and you can search by these tags or by these categories. All right. So then we have one of these, and you have posts. So you have the first one, and then more posts in that thread. So it seems like, I know my first thought of how to create this was if we had, oh, I don't want to create, I wanted to create a table. Let's uncheck that on the left. I'm going to create a table name for them. Or is this, oh, that's interesting. Forum threads, forum posts. I'm trying to make it a little descriptive as to what each of the rows kind of mainly describe. Because a property of the post is going to be which thread it's in. That might even be the partition key. But if we choose, okay, so partition key, let's say this is, hey, good morning, Mario. How are you? So, I used to be a banker, but I lost interest. And if you have clean bad jokes, feel free to tell them in there. Well, let's say that this is the thread ID. So if we're coming back in here, and maybe the thread ID is this string here. So it could be looked up, just say, give me this, and what is this number at the end? Is that, I have no idea. Is there a way to link to something further in? Like what is this? Can I link to? Oh, is this the same Alice that's in Discord? Yep. Man, Alice has answered so many of my questions in Discord. So if I click on this, okay, it does give me that. Oh, I see, but the URL then has /3 in it. So I wonder if this is just another term for this. Do we get to the same place if we remove the 51310 at the end? Do we get the same? Oh, we do. It actually redirected us. That's interesting. All right, so we'll pretend that this is, I don't know what the 51310 is. If we took this section off it, I'm expecting that to fail. Oh, it looked it up and found it and redirected us. So these might actually be the same value. Okay, so we'll treat those as the same thing. And then they have like /4, whatever, so you can link to the individual post in that thread. All right, so coming back to DynamoDB, we had thread ID. Oh, and how do we do pages? Is this one long enough to have a page? Hold on a sec. And we're back. We had a spam call. All right. It doesn't look like there's pages here, but I imagine that you, like if we wanted to do pagination, we could say it's like page 4, right? And then we would know maybe the quantity or whatever. And we could say, oh, we want post IDs that are greater than such and such. All right, so coming back here, we'll say this is a thread ID, and sure, it's a string. We're also going to add a sort key, and in this case, the sort key I mean, we could do post number in that thread, or that could be something in the GSI. Maybe this is, let's say this is number, and this just increments, right? And that would answer the question here, like how do we directly just get this, pull some data out of the URL, and start to fetch data that could be displayed in a forum. I wonder who created this. It's pretty interesting. About. So we do that, but it feels like the sort key isn't quite right. Because in some instances here, we're not actually linking it to something else. Like, what if we wanted to answer the question of somebody's posts? Let's go back. So let's say we wanted to see all of Alice's posts. Can we do that? Oh, we can filter based on, to posts in topic. So we can see only her posts in this topic. That's interesting. But it doesn't look like, in this case, we can find everything that Alice has done. Activity, I thought I saw it there. Top replies. Okay. So how would we render this information? Of course, it looks like we have date, we have some sort of heart, like a thumbs up situation. What else do we have? The posts themselves. Oh, I wonder if that number at the end differentiates between two topics that have the same title. Like, what if two people asked about set interval in Rust? So yeah, that post number doesn't seem correct here. that just might be some extra index. Many applications. So maybe this pattern isn't the right one to use for this. But it seems like it, right? This is for the many-to-many relationship. It's not exactly though, is it? So we'll have a thread. Thread will have a post. The post will have an author. I guess the post author and author to post is many-to-many. So in this case, maybe this is just, yeah, posts. This is post ID. And then like author ID. And sure, let's make that a string as well. And then we would have some sort of global secondary index. And that could be on the thread, which would be a property of the post. And then the sort key would be the date. Interesting. I wonder in the API, the DynamoDB API. So going down that train of thought, if we went through with this, let's just go ahead and create one of these. And here we have form posts. Sure, it's being created. And then we wanted to create secondary index. I think this is where we create the, global secondary index. Because if we did this, then we could say the partition key is going to be the thread ID. And the sort key is going to be data, whatever the data thing is. And that could be a date. Now, over in this example here, I think they end up overloading these. I'm going to see why they're overloading it. Because so this would answer two of our questions, right? It would say, okay, give me this thread in a specific order. It doesn't let us then filter based on, let's say, which post it is. But given this information, we could then filter it down. Or maybe you just don't have pagination, whatever it is. Okay. Let's say we only wanted to have, we wanted to include the post ID, just so that it's small. Because if we search on this, we would get the post ID back, and we can then just give me all of these posts for this thread, filtered on the date time. I don't know. That kind of fits. All right. I'm kind of hands-on, like a hands-on learner. I like to kind of make things as I'm learning through it. So for me, like having the little exercises at the back of a chapter, like I'm that person. I'm going to go through and build those out to really, like, I don't know, instill that and to preserve it. Because if I do that, I'll retain it a lot longer than if I just read through it. Some water, out of coffee, which is good. I feel like I should just go through and watch that too. Okay, so practical example. Northern Wind database. We've seen this already. If you're following along, the link is over here. Also, we have other commands and whatever. I know you can't see. Usually people are interested in what the theme stuff. We'll ignore a couple of the ancillary tables to focus on the big A: categories, customers, employees, orders, order details, etc. Define the access pattern. So first they build up a series of questions. How will this be used? Then, all of these would be simple in SQL. Yes, we understand that. Create a DynamoDB table with 3 generic attributes. Partition key. See, they say generic attributes. Partition key, sort key, and data. So maybe we should just call that like partition key, sort key, and data. Okay. We're gonna go ahead and let's create another table. Create a table. We'll call it forum. Partition key and sort key. I do not like spaces. Not like that. And data. 3 generic attributes. Okay, but does this mean that... Okay, I'm gonna assume that partition key and sort key are mapped to the partition key and sort key here. Now, it does not say what type these are. I mean, they could be binary, they could be something else. Attribute names have no relationship to attribute values. This brings us to one of the most important precepts in DynamoDB single table design. Attribute names have no relationship to attribute values. I see, so it's kind of context-based. So based on what you're looking for, you'll find it there. Not only is our key value store schemaless in a way, it's also keyless. Wow. Okay. We need to get used to thinking of the attribute names on a DynamoDB item as arbitrary. That is hard for me. Just think of it as arbitrary. The value defines it. Our partition key attribute on the table may contain a different type of value depending on whether it's an order or product or employee or whatever. Okay. So in this case, they just use PK, SK, and data. Let's mirror that. PK, SK. And we'll say they're strings. I'm sure they might look like strings here, but behind the scenes, they probably end up as binary. All right, default settings, fine. PK and SK. Our partition key attribute on the table may contain different types of value depending on whether it's an order, product, employee, or whatever. That doesn't partition it very well. Doesn't that create a hotspot? Or do we not care about hotspots? All right. Tell us more. Storing different types of data in the same attribute feels weird and squicky. Define this, please. I mean, squeaky, sure, but what's a squicky? Huh. A feel of disgust, distaste, nausea, or revulsion. All right, word of the day, squicky. All right. So now we have a form. We've got a partition key and a sort key. It's called index overloading, and it will enable us to squash tons of access patterns into a very small number of indexes. Okay. The 3 generic attributes will be used to support 2 indexes. Oh, we didn't create data, did we? I guess, how do you create data? Data is just a column that you provide. This technique is called index overloading, and it will be used to squash tons of access patterns into a very small number of indexes. The 3 generic attributes will be used to support 2 indexes: the main table, which uses the PK as a partition and SK as a sort, and a global secondary index, which uses the SK as the partition and data as a sort. Okay, so let's kind of codify that. Create index, SK, and sort key, data. Guess it's going to be a string. We just use strings. Index name. Sure. SK data index. All? I don't know about that. I mean, we could go with all. But that means we basically have a second table. Yeah, we're going to hold off on hitting create on that. And a global secondary index, which uses SK as the partition key and data as the sort. Okay. These 2 indexes, as we'll see, will open up a huge number of access patterns. The other attributes in the table can be named whatever you want. They don't have to be consistent between items. But even if you give every attribute of every item a random name, it doesn't affect the behavior of the table at all. It just makes the table layout harder for humans to read and understand, as we'll discuss further below. Okay. Create an item in the DynamoDB table for each record in each entity in unjoined table. I see. So in this case, they're just filling it out based on the stuff that we saw above. Oh, interesting. I like their compound key. They're using pound as a separator. You'll have to escape that. Interesting that the partition keys are the IDs of the rows. So you have order ID, you have product ID, you have employee ID. So these aren't fixed. I thought that wasn't going to be that way. I thought that was going to be like order and product, but it makes sense to have those as partition keys. But for the GSI PK, I mean, it's not a very good partition key for that. How order has the word order as its partition key. All right, I'm gonna try to scan ahead a little bit because I want to answer the question on whether or not we include all keys only or include. What do we actually want? Maybe we'll just keep reading. Although I would like to kind of follow along in their example. Okay, for that we will say all. Let's save that. And then later we'll know whether or not that could have been trimmed down. Because that basically doubles the cost. I know, I'm guessing I'm rounding. Alright, so where were we? We were... come back down. Alright, so we're going to create some entries here. So, creating an index. Items. We will create an item. Primary key. This is going to be, I don't know, some UUID. So let's create the author. That's our UUID. I'm just making it human readable. SK would be author. And data. I have no idea. What is the data going to be here? We'll just hit save. One or more parameter values are not. Oh, I have to fill that in. I don't know, unknown. Okay, item. Let's say this is a post. Post 1. Post. And the data here will be, what the date? Box times. All right, let's just toss that in there. We might need that in a moment. When it's not a number, maybe that should be something else. I don't know. Because if we sort that as a string, things go funny. It's a better way to sort that. 2020. What is today? 11/11. So year, month, day. Hour, minute, second. So 08/44/30. Save. That might sort as a string. So we toss both of those in there. And we also want a thread. Although threads might be properties of posts, huh? So maybe let's edit this and insert string, sure. Thread 1. We'll just save that. Okay. So now we have thread ID, got our post, we've got an author. Still not sure on the thread ID. We'll see. So let's say we didn't want to do a scan, but a query. Oh, maybe we should be using a combined property for our data here. Maybe it should be the thread ID followed by the date. So maybe that should be thread 1, pound, like that. What save there? Get rid of the other piece. How do I delete this? Remove. Okay. And then we could say, oh, we want all posts that has data greater than or equal to thread 1, pound, 2020, 1108. Sure, and everything that happens before a certain value. Oh, but interesting. So this is either going to be a between or a big. So maybe this is really a between, because we're going to have to fill out the rest of this. So 2020, 1108, we have to give it the time. Otherwise, the string comparison doesn't work. What if the thread ID isn't a fixed length? How is it doing the string comparison? So if we do that, start our search. Cannot read from backfilling global secondary index. Oh, is it not done? Looks like it might still be working on it. All right. Oops. Click off that. Oh, maybe it's okay now. Items. SK. Ah, good. Okay, so, but nothing was found. 2021, 1108. Hour, minutes, seconds. I think that works, but it's not. Let's see. Begins with. Start search. Odd. I thought that's what our data looked like. Because the SK there, its partition key is going to be the, let's say, search. Post 1, author 1. Where else? Oh, I see. We had it off by 1. I think I might have screwed that up. Let me check the index again. Oh, our PK is the SK, and the SK here is the data. Okay, so that is correct. It was just showing us the items that returned. Start search. Yeah, so nothing actually changed there, even though. Okay, let's do a query. Oh yeah, SK here is going to be post. So just find all of those. Great, that worked. Data string. Let's just say it begins with. Okay, so that still returns 1. If we do 2020, well, how about is greater than or equal to this? Start search. Twenty 11 08 44 00. So instead of using 30, we're going to do that. Okay, so it is returning the right thing. And then if we had another post to the same thread, its timestamp would differ. And yes, we might have to have some sort of finer grained post or timestamps, whatever it is. That's manageable. so coming back to here. So we have basically order and product. Then here we have employee, which has an employee ID, and who they report to is the SK. Interesting. Okay. Then their hire date is the data category. That must be the product category. It has a category ID, category name, and the description. So why? I wonder how category ends up relating to product, because to me this category maps very close to, or was it to these topics? No, not the topics. The categories here. Let's go back one. One more. Yeah, these categories here, which happen to be these little tag things. So I want to know how to associate the categories with these. I think it marries pretty closely to what we're doing here. So instead of order and product, we have author and post. But then we also want the category. The order product and supply records use a static value as a partition key for GS1. This lets us look up the items of a particular type, such as all the orders that match the date range. All orders that match a date range. I see, because even when we search based on the secondary index, we get the PK of the table back, even if we're looking for post. Like if we're searching for this post term here, we can basically use SK in the data of the table to find out what its partition key is. All right. We've used a composite key, a composite value called a hierarchical sort key. Hierarchical. That word for me. Sorry. We've used a composite value called a hierarchical sort key as the data field for the customer and supplier records. By combining all the address details into one field, we can get country, region, and city lookups for the price of a single GSI. How would you do a city lookup? We use the discontinued value as a sort key on the GSI for product items. Assuming we only populate that value for discontinued products, which isn't true in the raw Northern data, we can search for discontinued items without having to scan the entire product partition, the sparse index. We see sparse indexes also with entity component systems. Okay. We're basically playing Tetris with our data at this point, sliding different values in and out of our limited GSI slots to get the maximum utility. And we're not done, because we still have to represent many-to-many relationships with adjacency lists. Okay, and that's what we looked at yesterday a lot. In the Northwind dataset, the many-to-many relationships we'll focus on is expressed in the order details join table. An order can have many products. One product can appear in many orders, and the attributes of that relationship are expressed in the order details. We'll model this relationship by placing the order details records in the order partition of our table. Alright, so in this case they have an order record as an order ID. So they have this in there multiple times. So an order ID ends up having multiple elements. So first, that order ID has a quote-unquote order, followed by a customer ID and additional properties there. Then it also has a row for the product ID, the unit price, and then quantity and discount. I see. And that's interesting because you could then look up, what are we selling this product ID at? Like you could look up a history, because people might have like coupons or whatever, and you want to know, what are we actually selling this thing for? Now we have the ability to query the primary table partition to get all of the products in an order. We can query the GSI PK to do a reverse lookup on all the orders of a given product. Right, because you could say, oh, I want to look for all product ID 1, but then have an order ID. And that's assuming that your GS1 PKs don't conflict. So in this case, they prefix it with product ID underscore 1 and product ID underscore 2. This is the adjacency list pattern. You can try it yourself with the employee territories join table in the Northwind data. And then here we have the products, the product ID, whether or not it's discontinued. I see. So instead of doing it this way, we could have, let's say, so we go back to a scan real quick. We could have tossed in there, for this, we could say post 1 and then thread as the SK, like the thread ID. So create an item, PK, that's going to be, was it post 1? And the SK is going to be thread 1. And the data, let's say this is the order 0001. So then we could see, give us all the posts and their order in there. Well, let's go ahead and create another item. We'll call it post 2. SK is going to be a post. Data, I forget. We'll just say it's unknown at this time because I think I put a little too much information in here. We'll have to see. And then going back to that thread, create another item to join them. PK is going to be post2, SK is thread1, and data is 0002. And then if we wanted to find all, okay, let's do a query. We want post and the sort key. I'm gonna not do the sort key. Can I just not provide that? So for thread 1, yeah, we can get each one of these elements. That's neat. So now we know for thread 1 that has post 1 and post 2 in it and their order. And then if we wanted to find the author for these, we can then look at this. Let's go back here, scan. Because maybe the author is going to be a column or something. Okay. Or that undefined bit here. Say this is the author ID. I don't know why we would want that, but this unknown for post and this thread ID. I just want to change this. Author Alice. And here, author Bob. I do not remember what we were setting for this. Yeah. What's kind of getting me is sorting based on strings here, because we don't really have a known data type. So how do you sort? Especially if you put numbers in here. Can it sort numbers correctly? So let's say we had, edit this. Let's say this was the 9th and post 2 was the 10th. So we're going to get all of the posts for that thread. So we're going to look up here. We're going to do a query where we want post 1. All right, we want to sort ascending or descending. Oh, thread 1? All right, so then we have thread 1. Yeah, ascending and descending. What is it sorting on? Is it sorting on the partition key? No, I can't. Must be the data. Because post 2, T comes after O. So it's looking at the data here. So you have to know to construct these values in a specific way so that they get sorted properly. A lot of string padding then. It feels like you're using a lot of strings here. And while these could be other types, other than binary, it seems like it would limit it. But then you have to worry about the binary representation of these things and how they would sort. Okay, come back to the list. What does this get us? We now have the ability to query the primary table partition to get all products in an order. Yes. Because we can just search the PK by order. We can query the GS1 PK to do a reverse lookup on all the orders of a given product, which is nice. This is the adjacency list pattern, I say. And that ends up being kind of the join table, right? Yeah, I'm seeing that now. So the second and third rows there are basically the join table, where you have the order ID, the product ID, and the data just happens to be a unit price. You may need to break this access pattern out into its own GSI if you take it much further. Now here they have GS1, and here they have GSI. Optional, create more. What's GSI stand for? Global. Sort index? Well, more, access, tags, overview. Alright, do not see it in here. Capacity indexes. I think it's this here. And this is a GSI. Type is GSI. It's not GS1. Contributor insights. Huh, interesting. Triggers and more. Access, control, and tags. Okay, I'm guessing that it's this guy here is it's the one that they're talking about. The difference between GS1 and a GSI. I guess GS1 is just the first GSI that you create. Create more GSIs to support addition. Oh, okay. Create more GSIs. Yeah, that answers that. So the GS1 is a GSI. Believe it or not, even with all the tricks we used back in step 2, a single GSI may not be enough to support every possible query. Shocking, I know. The good news is you can add additional GSIs, if needed, without totally disrupting your carefully pieced together Tetris board. The DynamoDB docs have a good example of adding a second GSI with specially constructed partition and sort keys to handle certain types of range queries. In our case, though, the main table partition plus one GSI are more than enough to handle all of the use cases we define in step 1. Let's break down the queries. Get employee by employee ID. I see, so I'm going to have to do this for forum. Employee by employee ID, main table, etc. conditions. I like that they spell out their conditions, because this is basically how do you query it. Index here is going to be what we have in the dropdown this here. Which one are we looking at? Are we looking at the main table or the index? Man, I used to be indecisive, but now I'm not so sure. All right. You can see working examples of all these queries using the AWS Python SDK and the accompanying repo. Plus, we've preserved individual key value lookups of every entity in the table, so we haven't strayed too far from DynamoDB's roots. So I wonder if they refer to their indexes as GS1, GS2. So instead of naming it SK Data Index, it would be named GS1, which might make more sense here, because the indexes are fairly arbitrary. Can we rename this index? Let me rename it. Show hide columns. No, I'd have to delete it and create it again. Let's go ahead and do that. Okay, create an index. I'll call it GS1. Oh, partition key. We want both of these. We want SK and data. GS1. I'm gonna leave it lowercase so I don't have to hit that shift key. And basically, if we do all the attributes, it basically copies this. This means we have two tables, doesn't it? Local secondary index queries can also return attributes that are not projected by fetching them from the table. Global secondary index query, GSI queries can only return projected attributes. Okay. Local secondary index queries. I see. So this here is a global. Is it a global? Wait. Global secondary index queries can only return projected values. Those are copied attributes. Local secondary index queries can also return attributes that are not projected by fetching them from the table. So is this one local or global? We create it. How do we know if it's global or local? Are global ones for global tables? Add a region. I have to enable streams. Alright, so that one's deleting. Global secondary indexes, GSIs. Well, how do you do local secondary indexes? They seem to. So we have forum over on the left. So we'll select that. Go to actions. Just groups. Choose a table. Oh no. If we create a table. No secondary indexes. Okay, so the other ones are global indexes, so we could have a secondary index. What's the benefit of secondary indexes here versus the other one? Secondary indexes allow you to perform queries on attributes that are not part of the table's primary key. Note that global secondary indexes read and write capacity settings are separate from those of the table and will incur additional cost. So why would you want to have global secondary index as opposed to one that's specific to the table? Oh, it's specific to the table. Are the global ones across tables? Because if we have secondary index here, wow, okay, let's go back. Oh, I cancel out of here. Cancel. Let's say I click on forum. Because here we have this index. This text here seems to suggest that we're going to be creating a global secondary index. Let's create a new table. Let's call it forum with index, partition key, and sort key. So we're going to have pk and sk. We're not going to use the default settings. We're going to add an index. We'll call it gs1. Oh, partition key is going to be sk, and then we'll have data. We'll call it si, I don't know, secondary index. Feels weird to call it gs1. Just say secondary index. Now, the projected attributes from, oh look, this one has create as local secondary index. So it's a ls, okay, we'll call it ls1. Why can't I choose that box? An index that shares the same partition key as the table may be created as an ls1. Oh. Because it doesn't have the same partition key. Well, that answers that. The difference between a secondary index on a table and a global secondary index is that you can have different partition keys for a global secondary index as opposed to the secondary index, which has to have the same partition key. So if we did pk here, yeah, now we can check the box. And if we go back to sk, then the box unchecks itself. Okay. All right, so we're going to cancel out of this again, because the whole reason I was looking into that was to avoid the duplication of data for the forum in the global secondary index. So let's create this. Let's just call it GS1. So the primary key here is the SK, add sort key, and that's going to be data. And we'll call it GS1. All projected attributes. Otherwise, we have to do a second query. So either we store it, we double up the storage, or we do more than one lookup. I don't want to do the extra fetch for those. Okay, so we'll just create that. In our case, though, the main table partition plus one GSI are more than enough. Yes. I want to look at this again. Get direct reports for an employee, where SK is the employee ID. Get discontinued products. Yeah, we saw that. SK's product data is 1. Interesting that it's 1 product ID. I thought they said that they had like true or something in there. I guess it could have been anything. a sec. When you create a piece of data, let's go back into items. Let's say we want to create an item. Can I change the type of data? Or is it fixed as a string? Remove. And let's say it's a number. I call it data 3. Oh. Okay, primary key, let's say this is post 3. SK is going to be the author's ID, author Bob, or no, let's say Alice response. And the data is 3. So we can save that. Oh, one more per O. Type mismatch for index key data. Actual, expected S, actual N. Why, come on. Really? You couldn't say string and number? Shame on you, Amazon. Shame, shame, shame on you. I guess that this is probably just some sort of value that there's actually toString to. Okay, so that's still, I was testing to see if I could change the type on that. It doesn't look like we can. Just too bad. Because I saw this discontinued here and I was thinking, well, maybe it's the word discontinued. Maybe it's a Boolean. Maybe it's something else. Yeah, they use the string discontinued. Okay. Where's their query here? Okay. Get discontinued products. They use GS1 with the SK as product and the data as 1, which is incorrect. This should say discontinued. We found a bug in the post. List all orders of a given product. Okay, yeah, we see that. Because the order ID is going to be in the associated list rows. Interesting that you can do a limit on that. Get the most recent 25 orders. Now this product ID here, the 4th row there, lists all orders of a given product. So if you say we're using the GS1 and SK as a product ID. So if we come back up to their data, just here, I guess the only thing in there, because they don't use product ID for any other purpose as the GS1 PK. Okay, that works. List all orders of a given product. Sure. Get the most recent 25 orders. This one raises a question. Does it always return? How do you represent that? How do you actually do that? So in this case, they're saying, oh, we're using the GS1, and so we're not doing a scan, we're doing a query using GS1. And let's say we want whatever it is. We can have ascending and descending. Can we do a limit here? No, we can't. So what order do these come back in? So let's say we wanted all the posts for thread 1. It's actually going to sort based on the data, which is not what we want. And if we did toss a limit on there, it would give us the wrong limit. All right, just good to see. So they're searching for order and limiting 25. If we go back up to their little list here. Oh, I see. They have the order date. Okay, that works. That works. Because it would sort based on the order date. And that would have to be some sort of string. Because it looks like all of these are strings. Get the shippers by name. Or SK is the shipper name. Contacts by name. Fine, fine. List all products included in an order. SK begins with product. Oh, I see, because you have to filter out the other things. You can see a working example of all these queries. Yep. What can't we do? Ooh, I like the negative here. We now have a basic blueprint to convert a relational database into a single DynamoDB table. But remember, this is a spray foam approach to data. Spray foam approach. Like insulation hardening the contours of a ceiling, where DynamoDB single table data model is both informal and inflexible. It's not necessarily going to accommodate new access patterns. Ah, I see. So it's filling the space as opposed to, okay. That is a weird metaphor. I mean, how many people know that they use spray foam for insulating ceilings? Anybody? I mean, this is really kind of specific to that industry. For example, suppose we need to see all products in a given category. Greg Burns says, spray foam basically, let's see, hold on, Museum says, spray foam basically because rock solid and the only thing you can do afterwards is remove it. Okay, yeah. For example, suppose we need to see all products in a given category. Product record has a category ID, but records have a category ID, but it's not included in any of our indexes at the moment. Indexes are options are query all products, filter by category ID, or break out new items in one of our existing partitions that index product data by category ID. Creates more duplicated data, which is potentially harder to manage, or create a new GSI with product ID as a partition and category ID as a sort keys. Yeah. But it's interesting because you either incur cost by increasing the duplication of the data here, or you increase the cost by duplicating the data here, and you might have to make more than one query. Because this might give you an answer that then you need to, fetch more data. So you incur the cost of 2 queries as opposed to 1, or the cost of storage. Well, I guess this one also has storage, doesn't it? Storage and extra queries versus just extra storage. Those are interesting trade-offs. I can't intuitively determine which one would be most cost effective here. It's fluid until you set it, and now you can't change it. Yes. A well-optimized single-table DynamoDB looks more like machine code than a simple spreadsheet, despite all the bespoke human finagling it took to create it. Is modeling my relational database in a single DynamoDB table really a good idea? About a year ago, I wrote a fairly popular article called Why DynamoDB Isn't for Everyone. Many of the technical criticisms of DynamoDB I put forth at that time, lack of operational controls such as backup restore, a persistent problem with hotkeys, etc., have since been partially or fully resolved due to a true awe-inspiring run of feature releases from the DynamoDB team. I wonder when this was actually written, as how many years ago was this? Oh, January in 2019. Okay, going back down here. However, the central argument of that article remains valid. DynamoDB is a powerful tool when used properly, but if you don't know what you're doing, it's a deceptively user-friendly guide to madness. Oh, I like that phrase. A user-friendly guide into madness. Wow. And the further you stray into esoteric applications like relational modeling, the more sure you'd better be that you know what you're getting into, especially with SQL-friendly serverless databases like Amazon Aurora hitting their stride. But doesn't this have an absolutely horrible startup time? That said, remember that Amazon's original Dynamo paper was predicated on the observation that most interactions with their vast Oracle databases were simple key value reads, no joins or other relational magic required, which makes sense. All right, in the same way, a lot of superficially relational databases boil down into a relatively small number of usage patterns. If you can work through the steps in this post to identify and implement those patterns for your data, DynamoDB's scale, performance, and low operational overhead may seem more compelling than ever. Unless you're still a big fan of Microsoft Access. Oh, that takes me back. Over 20 years ago, I made Microsoft Access applications. Well, that was a good article. I did like that. I definitely had to go through some of these other pieces to start to understand what they were talking about in here. That is interesting. I wonder how we would describe the table in our application. All right. So I think the next step is going to be, oh goodness, it's going to be building up the list of questions, right? Because that's what each one of these tutorials starts with. What answers do you need questions for? Here we go. Define the access patterns you think you'll need. That's like number one. All right, so I think I'm going to build out a forum first, just to get a handle on this. I think that's the, I guess, cleanest approach here. Squiggly. Oh yeah, word of the day is squiggly, by the way. I wonder how quickly these queries come back. So when we're looking at this, if we go to F12 here, just got a network, good. Start a search. Hold on, clear it again, I wasn't watching. That seemed almost too fast. Response. Interesting that they're doing that. Parameter out. Success. $252 milliseconds for that first response. I mean, it seems like a very long time. Quarter second. It's probably got a very sort of even scale out to it, doesn't it? All right. Oh, that's right. There were also metrics. Forgot about that. Latency. Here we go. Foot latency. Query latency, 15 milliseconds. Scan latency. If you're doing Amazon to Amazon. Yeah, I'm thinking Lambda to DynamoDB. Because if we had to do multiple queries to fill out a page, we're looking at, let's say, 100 milliseconds, maybe, to get all the data. Because if the response here actually requires that we fetch more data for our quote-unquote joins, either that or we're duplicating data, which is fine too. So maybe we do just include everything that we need for displaying the row or the post. There's all sorts of possibilities here. All right. I think that my next stage is really going through and looking to see what sort of questions I want to answer for this forum. So I'll probably do design stages tomorrow, and I might do a little bit of homework on this. But depending on my load at work today, I might have a little time. But I don't know, I've been pretty busy at work. So I'm gonna have to bail and close this. Come back over here. How'd that work out with the chat at the bottom of that browser window there? Was that helpful? All right, I'm gonna find somebody to raid. Let's see, who do we have? Gamozo. Wow, that was weird. I did a search and it just didn't come back up. One of one? Ah, there's trust. Somebody had trust in their stream title. I'm not finding many Rust streams at the moment. All right, Gamozo it is. Well, until next time, y'all. I look forward to getting back into the Rust side of it, wiring that up, getting that sort of little test project up and running. Until next time, bye bye.